Hi, everybody. I'm Marianne with the Staupell Analytics Group, and Greg, I'm going to introduce you if that's okay.
That's fine.
I'm here with Dr. Greg Duke, our Duke of Excel, who's also, every time we start learning something new, we get on a tear, and Greg's tear has been probability, and he's done some amazing research on it, and we're starting to use it for our clients. Greg has also just heard his severe weather storm signal, and so if he um, suddenly stands up and leaves, I'm just going to pick up where he was. And
I'll probably disappear before before that happens. If my power goes out,
oh, right,
yes. So Mary will take over. I did
right.
send her this. So
I'm going to have a copy of Greg's presentation up and ready to take a step in for him. I just will not have your academic sense of humor. So
and
it's
some
going
of
to
the
be,
weird things on the slides won't make sense.
it'll be weird.
Okay.
Yes, it'll be weird of tonal transition. So please go ahead. And Ruthie, our other team member, is joining us as soon as she can.
All right. Well, thank you for that introduction, Marianne. My name is Gregory Duke. Some of you may have seen me at New Orleans at the Case Drive conference down there, where I made a version of this presentation. Um, I said at that conference that I've loved working in probability since I was a kid. And I was one of those kids that collected baseball cards, and now I actually collect playing cards, and I've done a lot of work in building games and other things with probability. One of the other things I said at the New Orleans conference was that I also went to New Orleans to have some beignets, and of course here in Louisville I can't do that, but I did pick up a box of beignet mix, so hopefully it'll be close to uh, what we had down there, although I'm not as skilled in that as I would like to be. So one of the things I've learned over the years with regards to probability is a lot of people don't want you to know how probability works. And a perfect example of this is the continued success of casinos, not just in Las Vegas now, but all over the country. And I admit that I have lost a bit of money in Las Vegas myself, but knowing the how odds work can help you raise money and also save money. And I'll get to that in a bit. But one of the ways that probability can save you money is by knowing what games are bad in Las Vegas casinos. And technically, the answer is all of them, unless you know how to count cards. But I won't go into that right now. So when I started this, I asked myself, why is identifying the probability that someone will make a gift important? And I really came up with two very important reasons. The first is that you have limited resources and you want to spend your time on prospects who are most likely to gift and make a gift. And the second reason is you have limited resources and you want to spend time on the prospects who are most likely to make a gift. Now, I realize that this is technically one point, but it's such an important point, I wanted to make it twice. And I stole that line from the sci-fi show Red Dwarf, and this character Cat, when the Rimmer made that point, he said, Cat replied, "Good point, well made." And it was something that my first wife and I would often quote to each other when we had to make a decision. Sometimes we make the same point twice, and the other would say, "Good point, well made." Some of the other reasons, well, you may want to plan out your organization's fundraising strategy. And this is something we've done with Staupell quite often. In fact, the first time I started really working with this was with a client that wanted to know the best optimization for their budget when it came to contacting their prospects. How many prospects should they send a letter to? How many prospects should they call? And how many should they just email? Knowing what their budget was and how many letters they could potentially send out, how many calls they could make which prospects were most likely to give a good return on investment for those strategies. You may want to know what your likelihood of reaching your campaign or annual fund goals are, and you may want to try and determine what those goals are based on how likely your prospects are to give. And lastly, logistical planning. Where are we going to go to meet our prospects? Literally, what method, but also where in the country, if where prospects live. Is it worth it to go to somewhere the whole way across the country, or is it better to work locally? Uh, Identifying probability of giving can help you identify that. So first, I did want to talk a little bit about how probability works, because as I say, a lot of people don't want you to know how probability works. So the first thing you need to know is how to figure out the probability for one event happening. And as Mary Ann knows, and some of you who know me know, I've been collecting playing cards for the last 35 years. Um, and my first really serious work in probability was in identifying probabilities for card games and identifying how what the probability of certain cards appearing was. And so if you draw a card from a regular deck of playing cards, what's your possibility of getting the ace of spades, for example? Well, if it's a deck of 52 cards, each individual card has a 1 in 52 chance of being drawn out of the deck. But something to know about cards is that not all decks have 52 cards. Some of them have 53 because there's a joker. Some might have two jokers, so there's 54. Some decks only have 36 cards if you're playing the game Ballot from France, or Skat from Germany, Skate from Germany. You have 36 cards. I have a deck here that has 63 cards because it also includes 11, 12, and 13. And I also have a deck of cards here that has 78 cards. This is a Tarocco deck from Italy, and so it's like kind of like the fortune telling decks. It's got 22 trump cards, and this happens to be the Pope card. So you have to know when you're trying to identify the probability of event happening, what the potential possibilities for each possible outcome are. So you may have we're going to be talking obviously mainly about binary events happening. So a prospect makes a gift or doesn't make a gift. That seems simple, but first of all, we need to know that in cases like drawing a card, each event is equally likely to occur. We've got, in this case, a deck of 63 cards, and if we pull one out, this happens to be the Joker. It has just as much possibility of, say, the five of diamonds appearing, but we're going to be putting meaning to different sequences of events. So if we're playing a video poker machine and we get this, we're going to be jumping up and down because we just got a lot of money. But having a straight or royal flush appear is just as likely as getting any other five cards. It's just that we're attaching meaning to a specific sequence, in this case, a royal flush. We're not going to hit the jackpot if we get five completely unmatched cards, even though it is just as likely for this sequence to occur. And that's something that's important to remember, even if we're doing probability of giving, because we need to know that if someone has a 30% chance of giving, if we run a simulation, um, each probability within the simulation has the same possibility of occurring, but in 30% of those possibilities, in 30% of those simulations, we're going to assign meaning to the event, which is that they've made a gift. It gets more complex when we're starting to talk about probability for multiple events. Say we're trying to look at a list of 100 prospects and we're trying to identify what the likelihood will be that say 30 of them make a gift or 40 or 50. We can't just add probabilities or events together. And the simplest way to understand that is with a coin. Each coin has a heads or a tails, so a head or a tails. And each of those possibilities obviously has a 50% chance of happening. If we throw a coin, 50% of the chance, 50% of the time it's going to be heads, the other 50% it's going to be tails. Now, if we throw this coin twice, we can't just add those probabilities together. So we can't just throw the coin twice and say, well, 50% of the time it's going to be heads on the first throw, 50% of the time it's going to be heads on the second throw. Therefore, we're always going to have one head show up and one tail show up. But we have to remember that we could potentially have two events happen the same way. So we could have heads appear twice, and we need to add those together in a different way. We need to look at that by saying, okay, the possibility of having two heads is 25%, two tails is 25%. Again, those two possibilities have the same chance of happening, but again, we're assigning those two, I should say the two throws have the same possibility of happening, but we have to assign value to a sequence of two heads, or in some, if we're throwing it 5 times, how many times does 5 heads appear? And that has a certain meaning. The second thing we need to know about probability for multiple events, and this does come into play with prospects, is each event independent, or is it dependent on previous events? And again, the cards and dice are a good example. If I throw this coin twice, the second time I throw it isn't dependent on the first time. The coin isn't going to remember how it landed the first time. It's every time I throw it, it's an independent event. But cards are a little different, because if I draw, say, the Jack of Diamonds, and then I place it to the side, what are the chances I'm going to draw the Jack of Diamonds a second time? Well, it's 0 because it's not in the deck anymore. But the other thing it does is that now this deck only has 62 cards because I've taken one away. So my chances of drawing, say, the 4 of clubs are now 1 in 62 rather than 1 in 63. The second event is dependent on what I did with the previous event. And that can happen with giving. Now, this is a slide that I think Mary Ann's going to disagree with here. And that is that I argue that inanimate objects don't have memories. So theoretically, and Mary Ann's going to argue with this, there's no such thing as hot dice or hot numbers when it comes to casino games or lotteries or things like that.
It's not the objects, it's the goddess of luck.
I'm going to have to ignore that for now. I am going to admit that it is theoretically possible that the fact that someone is throwing dice may affect what they come up with. I mean, casinos try very hard to make sure that doesn't happen, but I have to admit it is a possibility. But when it comes to, say, a robot dealing cards in a casino, or this case, which I had to take a picture of because this is a computer-generated roulette wheel. Theoretically, there is no human involvement once the computer takes over. There should be no such thing as hot numbers when it comes to a computer-generated event. Despite the fact that they're trying to make it look like to you that, oh, the 27 is coming up way more than any other number. That doesn't mean that it's not going to come up a 10th time, or it won't come up for the next 100 times. If these are independent events and these are an inanimate object, they don't have memories. They don't know what's happening. They don't care who's standing in front of the machine. They don't even care who unplugs or replugs the machine in at the end. Well, Vegas doesn't have an end of the day, but they don't have memories. And this is where, if you saw my post today, horses are different from a deck of cards. Living beings do have memories. So if a horse hated running in the mud the first time, and this is a picture from this year's Kentucky Derby, the weather here was awful before the Kentucky Derby. You can see it looks just like a mud pit here. If a horse ran once in a mud pit and kind of tweaked its leg or something, it's going to have bad memories about that, and maybe it won't do so well in the mud next time. Um, and donors, hang on, I should go back one. Donors also have memories like living beings, like other like horses. Donors remember when things happened in the past. Donors remember when they made a gift and nobody thanked them. Donors also remember when they made a gift and someone did thank them. So donors have memories which make all events dependent on previous events. There is literally no situation where we can ask a prospect for a gift and um, there's no impact of previous events, whether that be a previous ask, whether it be an event they attended, whether it be clubs they attended when they were, say, if they were in school, or or just contacts with other people. I see we have a few questions here. Oh, no severe weather. Okay. Okay. Um, the other thing about our events, especially when it comes to giving, is that some events have multiple variables. Now, you may see this, this person is supposed to look like me, yes. This is from a very complicated computer game called Football Manager. It's made in England, so football is soccer in this case. And in Football Manager, there are more variables than you could ever imagine. Each player has 25 variables listed from 1 to 20. Each player has a reputation. Each manager has a reputation. Each manager has attributes. Each stadium has attributes. Each country has attributes. Um, some of us in the Football Manager community call this game a spreadsheet game. And you literally do sometimes need a spreadsheet to keep track of all the variables. By the standards of Football Manager, finding out prospect variables are relatively easy, but they're still pretty complex, as we'll see in the rest of this presentation. So identifying the probability of giving deals with both of these complications, that giving is dependent on previous variables and previous events, and giving is also determined by a large number of variables, some of which are dependent on previous variables. So knowing this, what are the principles we need to know when it comes to determining probability? And if you were at the New Orleans event, I said this at the New Orleans event, and I walked away from it thinking, man, I think I'm not giving anybody the wrong idea by saying, that this is determining probability is something that is nearly impossible to figure out. But I do think this is true, that there may not be a one size fits all probability score because of the implications of all these two principles, that there are so many things about our donors that we don't know. And there are so many things about a donor's past that we don't know that might affect their present. Now, obviously, we can talk to our development officers, and that is something that I'm going to get into later in this presentation. And we can very carefully mark down in our database as many variables as we can about our good prospects, and pull in things like demographic data, which I'll also demonstrate a little bit about today. But part of the issue is that we are not just trying to identify probability of giving, but we're also trying to identify ways to improve that probability of giving. And that's an important thing to take into account. And that will become clear as I talk about the things we are taking into account. So some of the things when I've worked in the past to identify the likelihood that someone would make a gift, I've looked at what I call database variables. These are the things that you can pull out of your database. Um, and so have they attended events? Have they identified have we identified things about them that make them different from other prospects? Have we, have how much information have we done with regards to research? And how can we build that into a variable?
Right.
Another thing, oh, go on.
Sorry. While everyone's pondering those questions, we do have a question from Deborah. What is the difference between probability scoring and propensity scoring, or are they the same thing?
That's a great question because I think in my view, propensity is an unlimited time event. So propensity is how likely is someone to give over a long period of time. And probability, at least as we are going to look at it today, is designed to look at a very specific length of time. The other thing I think about propensity is that propensity to me is looking at it takes inclination into account.
Yeah.
And inclination and actually making a gift is, as we know from our work with development officers, is not always exactly the same thing, if you see what I mean. Um, like I really want to make a gift to a lot of different places. My propensity and my inclination is high, but my
Mhm.
propensity may not be very high because I just don't have the resources to make the kinds of gifts I'd like to. And I think propensity falls somewhere between inclination and probability. Probability is just kind of the really raw chance of me making a gift. But propensity, I think, does take inclination into account a little bit.
I think of propensity as donor modeling, and when everybody said, let's go find a low-hanging fruit, right? So just build us a model that scores everybody and we'll start there. And then
Hmm.
probability is what is the probability of each of these people giving in the next couple of years? And I'm hearing you describe the same thing.
Yeah, I probably you made it a lot more concise than I did.
Oh,
That's good because
yeah.
I,
It's
I, I
always
tend to
easier to go
ramble.
second.
Yeah. That's true too.
Yeah.
So the second thing I usually take into account when it comes to probability is development officer input, and I'll expand on that in a bit. But development officers often can tell us things that we as researchers and database people cannot identify in a lifetime of research. They can identify by talking to someone for 15 minutes. And that something often is inclination, but it's also things like what is blocking me from making a gift? Why am I unhappy with your institution? The third thing I take into account are patterns of previous giving, and I'm going to show that example soon. That I think one of the things that we sometimes have missed in identifying probability in the past is um, when someone has made a gift and looking at how often someone's made a gift in the past and what times they've made those gifts. How likely are they to make a gift in, say, the next year or the next 5 years? So, database variables, the first thing we often do is trying to make sense of the things that are in our database and how to program them into a predictive model. One of the things that I've seen in previous, and I've even recommended in previous research on this project, is to take literally everything in the database and throw it into a model. So this is kind of the famous example of the institution that looked at everybody in their database who had a fishing license and throwing that in the model and finding, people who had a fishing license were more likely to give. And Yes, I do think it is a good reason to, throw everything into a model, but I've found that in my experience, it does make sense to kind of start with the things that look promising and go out from there. Simply because if you throw everything into a model, sometimes, first of all, the model crashes, which, if you're throwing, say, 150 models into a project. But the other thing is that sometimes you just come up with things um, that don't fit. You throw 150 things into a model and only one of them fits because you just have so much data in there. Sometimes I think you just need to start with the things that make sense to you. Um, you know, what major did someone have? Have they attended events and then kind of build out from there. And Ruthie has a good point about affinity and propensity in the chat as well. The second thing that I do that I've worked on those variables is to kind of correct for dirty and incomplete data. And there's a there was a good example here, and I'll kind of cut ahead to this slide. I used to work with a screening service that would identify someone's real estate holdings. And in their propensity, in their scoring, they didn't do propensity, but they did capacity. And you will see this in propensity models as well. If they couldn't find someone's real estate valuation, they'd mark it as zero. So what this ended up doing was if someone had a real estate valuation that was in trust, their screening service didn't find it. And so they marked them as having zero real estate. Then there might be some guy out near my dad's farm in Kentucky or where I grew up in Pennsylvania, and their little shack out in the sticks is valued at $3,000. Um, Technically, according to the screening service, they have more real estate than the guy who has all his real estate in trust and theoretically has a ton of real estate. And so we need to look at that and say, okay, does that guy out in the sticks, is his real estate actually worth more than the guy they couldn't find? And the way I sum this up is zero is not null. If someone really does have zero in real estate, that's different from I couldn't find what their real estate was worth. Oh, and I'm just gonna one of the biggest issues with this is trying to identify when something is zero and when something is null. And so this is a good reason for, say, leaving real estate out of evaluation and then running it again and identifying, okay, how much better of a score did someone get when they had zero real estate? If someone's getting a really high score when you don't include real estate, and then when you include the real estate, they have a real estate of zero, and it knocks them down a ton. Um, Maybe this is an indication that their real estate zero actually is a null rather than a zero. Um, let's see, so let me. And the last thing you need to talk about when you look at variables is, are we going to make this a binary variable or are we going to keep it as numeric? So obviously when you're doing a yes or no question, so has someone attended any events in the last 5 years, yes or no? You're going to make that a binary. But it's possible you might say to yourself, okay, in the last 5 years, someone has attended one, two, three events. We're going to keep that numeric to see if someone has attended three events, they're more likely to make a gift if someone's only attended one. And this is important if you have something that is going to be improving, theoretically improving your score. Um, it's possible that with some variables, you come up to a limit. Um, and this is something I think we've found in the past when it came to development officer visits. that at some point there was a diminishing returns. If someone visited 5 times, they were, likely to make it just about as likely to make a gift as if you visit them 10 times. So after that fifth visit, the valuation of your visit started to decline. And you can find that out through modeling. And if you do, then you can just say in your model, we're going to count this numerically, these number of visits up to 5. And once we reach 5, we'll just mark them as 5. Cap the number of visits at 5. Yep, Marianne.
So we're having some discussion there. There's some discussion about reviewing the difference between inclination and probability, which has been
Oh.
great. And Ruthie
Mhm.
just got an assignment for that. That's what you get for showing up, Ruthie. And but Michelle wants to know, she says the model will kick out the blanks, right? Would you recommend imputation for the blanks? Now, I've already stated my opinion in the chat. I said a good
Mhm.
model will impute the blanks as blank, but and then machine learning, of course, which I get all over, is also can handle null values as null values. What are your thoughts?
That's an interesting question because what I often do is if I know something is a null, um, then I'm going to replace that I might replace that in a model with an average score. So,
So you
say
would
the
impute them.
mean, yeah, so
Yeah.
recompute it or take a look at it and say, okay, this person has a trust. We know this person has a trust, but we also can't get can't get the real estate valuation. Well, let's look at, what the average real estate for someone who has a trust is and add that to the model. The other thing you can do is, simply realize, okay, here's someone who's a big prospect. Maybe we need to just do a quick real estate valuation, even though the screening service didn't get it. I
Or
mean,
maybe
that's
bring in some
possible.
stuff from the census data.
Yeah, we could pull median home value from census data. Um, and it just so happens I'll be mentioning that in the slide
Oh,
here.
oh yeah, yeah, it's coming up. I'm sorry. I didn't
Oh,
mean
that's
to
okay.
take away your thunder. And
Oh,
then
that's okay.
Radina says really matters on the context. I think it goes back to that expert domain knowledge, and I agree because
I agree.
while
Yeah.
I'm videotaping my beginner's Python class, that's what I talk about a lot. It's like
Hmm.
sometimes null really means null, right? Last
Hmm.
gift amount for a non-donor is null, but you're talking
Hmm.
about real estate values. And
Hmm.
so if I'm a renter, I don't own real estate, but what if I'm a renter in Saudi Arabia?
Or I'm a renter at, having looked at apartments lately and seeing like say a place in downtown Boston or downtown Chicago where it's $6,000 a
Yeah,
month.
God bless
Well,
you.
yeah, I'm definitely not gonna get those, but
Yeah,
but just realizing like that's pretty expensive. It's
yep,
it's hard to own real estate if you live in downtown Manhattan. But
yeah.
if you're paying a lot in rent, then there's an equivalency there. Um,
Yeah, so it sounds like our audience is really catching on to this concept. Like,
mhm,
don't take the screening at raw value. You've got to understand what it's saying to you.
mhm.
And if you figure out that there's something really missing, you have some choices, and so they're happy to discuss all the choices.
And I also think that it's important to look at the data just from a standpoint of it's it's never a good idea to kind of take everything and throw it into a box and hope that you pull out the right thing. I mean, you have to understand what you're getting from any kind of model. And it also, I think it just makes sense to look at that just to make sure it looks right. I mean, I pulled a screening at one institution and someone was listed as having $1 billion in real estate. And I didn't fall over immediately. I was just like, okay, that's got to be wrong. And it turned out that was the valuation of like this entire apartment complex that the guy was living in. And somehow that had been marked as his real estate holdings, even though he, obviously didn't own that. He was just renting. So sometimes just looking over the data to make sure that you're getting what you think you're getting is important. So now I may be a little early with this slide, but this is a typical logistic regression result. And I'm going to go now to Excel because as Marianne knows, every you can do anything in Excel. At least that's what I tell her. Um, hang on. Let's see. So this is the summary output from a data set. This is all dummy data that I've put together. Um, this has just some basic things like lifetime giving, donor, are they a previous donor? Yes or no. Are they male? Yes or no. Deceased? Yes or no, et cetera, et cetera. The one numeric thing I've put in was class year. And in this case, I built this, and it's so typical here that I can't like get to the I cannot get to the correct bar here. Um, I have built a regression in oops, in in Excel. Let me just get to the data analysis tool pack. So this is something that's free in Excel. This is the data analysis tool pack. If you don't have it, you can go to File Options and install Data Analysis Tool Pack. So all I did here was just highlight the columns in my data uh, and clicked regression, hit OK. You'll get this. The dependent variable in the column for the dependent variable is the Y range. The independent variables are the X range, and then you can choose your labels where you want it to go out, etc. And this is the result I came up with. So when we pull our data in a quick regression, the significant variables here are the ones that have a p-value of less than 0.05. And in this case, all of them were above 0.05 except for were they deceased and were they alumni. And we can see that these have an E value. E is Excel's way of saying this is a point with 162 zeros and then an 8 in the rest of the number. And this is E with 31 zeros and a 195. So these are obviously way lower than 0.05. Now, the next thing we need to look at is the constituents, the coefficients, and we see that the deceased coefficient is positive, the alumni is negative. What this means is that if someone is deceased, they're more likely to give because the coefficient is positive. If they're alumni, they're less likely to give because the coefficient is negative. Obviously, we've learned something here, but we haven't learned everything. And one of the things we learned is that because this is dummy data, the two things that were significant were the two I actually seeded for. But this is pretty much how I always start with looking for significant variables when it comes to giving. The important thing we've done here is that we made our dependent variable whether they gave or not. So in this case, we're trying to figure out the probability that someone will make a gift. We want our dependent variable to be donor, whether they've given in the past or not, and whether and we want to make this a binary variable. So yes or no, have they made a gift? If we wanted to know what the probability would be if for someone making a gift of over $1,000, we would have a binary variable yes or no donor over $1,000, and obviously and we can do that in Excel. We can identify that in Excel as well. Get back to this. So again, I talk here about incomplete data, and having identified our database variables, which are predictive, the next thing we need to identify is we need to go into our development officer input. And this is important because this will give us a bit of personality, as it were. Um, Sometimes our variables, when we throw them into a model, are they're a bit impersonal. We're guessing a lot of the time at what might be significant, what might not be. But then when we get to the development officers, we have a bit more understanding of what a donor looks like. And we also can understand what someone's thought process may be as to whether they're going to make a gift or why they're going to make a gift. The only drawback of this is we have to be able to, first of all, trust what the development officers are telling you. I worked at an institution where we rated all our prospects hot, medium, and cold for the next year. So are they likely to give a gift? They were really likely to make a gift. They were hot. Yeah, sort of. It was medium. If they were unlikely, then we were cold. And this seemed to me like a pretty, blunt instrument to me. So I decided to go back to the previous year and see how well the officers, the gift officers had predicted that they were going to make that people were going to make a gift, how good that prediction was. And I found that about 30% of the hot prospects actually made a gift. And when it got down to cold, it was like 2% of the cold prospects made a gift. And I was able to put all of that information into a Monte Carlo, and that I won't be able to explain that here. That's an entirely new thing, other thing. Um, and try to identify, okay, if a hot prospect only has a 30% chance of making a gift, how likely are we to make our goal for the year? And it wasn't very good. The other thing we can do with a development officer's input is look at what they are saying, what they have written down in their contact reports, and try and identify what I call red lights and green lights. What are people who are likely to make a gift saying? So I stole this slide from Marianne. Yep.
Sorry, just before you show them the slide you stole from me, Deborah says, "Isn't hot, medium, cold a self-fulfilling prophecy though? If DOs end up giving more attention to or even communicating differently with a prospect depending on this designation?" Question mark.
Absolutely. I mean, obviously, we have to take a gift officer's bias into account. And we also have to keep in mind that if we're looking at the past events, so when I looked at the previous year's giving, I realized that, they were doing the same thing the previous year. They were saying a prospect was hot the previous year, and they were more likely to meet the person that year too. So the important thing is to take a look at previous events, but make sure that they're actually predictive of this year's events. To make sure you say, okay, the development officers are going to do exactly the same things they did last year. They said that someone was hot last year, and they were more likely to visit someone because they said they were hot. And they're going to do this exact same thing this year. So that makes it predictive. If we said to someone, okay, tell me which prospects from someone else's portfolio are likely to give. We'd get a very different, I think, predictive identification. If, that gift officer managed not to visit their hot prospects more when someone else said they were hot. And Michelle says most donors self-select. That's true too. I mean, you know, when someone says they're going to be a donor, and this is a perfect segue into text mining. If someone comes to a development and say, "Hey, I want to give," we make sure that our development officer writes that down in a contact report, then we can do a predictive model on people who say, and one of our variables are people who self-identify, people who come up to a gift officer and say they want to give to, say, Big Red Hockey or sports or charity or whatever. And we
Or
can,
you want to flip to that slide.
oh, am I on that side? This
I
one?
didn't get that. Oh, Can you sorry. Try again? Siri would also like you to try again.
Okay. Am I on that side?
No, you're showing your Excel chart. We need to go
Oh,
back
yes.
to the
Sorry,
PowerPoint.
sorry. Yeah, that's Zoom for you. Okay.
I guess I said sorry in a Boston accent.
Okay. Can you see it now? Okay. So if we mine our gift officers' contact reports for specific words that are red lights and green lights, we can use that self-selection as long as the development officers are writing down their contact reports. And this is another good way of making sure that happens to say, we're looking for, we're looking at your contact reports for probability identification. Oh, yes. I'll get to that. I will get to that, Charles. When I get to the class here, but I need to go through this pretty quickly for. Um, I mentioned giving results, and this is something I've been doing a lot of recently. Um, Identifying giving pattern results for the matrix. So what I've been doing recently is looking at how many times someone has made a gift within the last, say, 10 years, and then assigning a pattern to that. So someone has made no gifts in the past 5 years. Their giving is just zero, five zeros. Their likelihood of giving is 21.28%. And as you can see, it slowly becomes more the more someone has given over the past 5 years. Um, Essentially what I did was just converted this matrix into Excel, replaced did they give yes or no with a zero or an X or an O and an X. The other thing you can do that's a lot simpler is just to count the number of times someone made a gift in the last 10 years, and look at the likelihood that they've made a gift. And I think although that's a very simple way of identifying giving and identifying probably someone will make a gift, I think it's important to look at the simple things sometimes first because previous giving is highly predictive of future giving. Oh, 13 minutes left. Okay, I'll run. So identifying actions and events. Again, this is a variable you can throw into your data model, but it is something you have to be careful with because everyone often assumes that a certain action or event um, is positively predictive. So, oh, someone had three actions last year. They're more likely to give than someone who only had one action or no actions. In the past, I've identified some actions and events as being negatively predictive. So someone who attended certain events were less likely to give. And that's a common mistake I think that sometimes we make in models that we assume things are necessarily going to be positively predictive. And I always my ex-wife Rachel Link that some of you may know, she always called this the hot dog event situation where some events uh, people would just show up to eat the hot dogs and drink the Coke or the beer and leave. And they were actually less likely to give than people who never attended the event at all. And so, using that model, she was able to convince her office to stop having what she called the hot dog events because they were costing the university money and they were making people like people who were less likely to give were attending. Oh, yeah, I had to use Nate. Yeah, well, it was the one thing I could think of when I was putting the. So one kind of stepstone I've always used for giving and identifying future giving is to use what I call the known knowns. And the big known knowns to me are age and previous giving. So it seems to me that everywhere I've worked, these have been the two standard giving variables that no matter where I am, people who are older up to a certain point are more likely to make a gift. And if people who have made a gift previously are more likely to make a gift. And that never changes wherever I go. So knowing this, we can kind of go into our whatever program we're using and take those two indicators and start using them to identify to kind of as I call it correct for those factors to identify likelihood of giving. So let me go to Power BI, which is a program that I have really started using a lot, not just for data visualization, but um, also for really just identifying key indicators. And the part of Power BI I use is a visualization called key influencers. I've taken the information that I've used for our previous segment, and here it's telling me that if someone is deceased, the likelihood that they are going to be a donor increases by 0.54 or 54%. If they're an alumnus, their likelihood of giving actually decreases. So alumni is zero, they're not an alumnus. Their likelihood of giving increases by 0.08, which is 8%. This is a pretty blunt tool again, but it's very good at kind of identifying um, significant segments in a visual way. So one thing, hang on, I'm just going to go to the other one here. So what I did with this data set was I took a look at, I added class here as a segment. And Charles, you are absolutely right um, that that class here is not numeric but categorical. I admit that I was a bit lazy here and did not convert this to years since graduation. I usually do that. I just didn't do it for a reason, for some reason here. But you're absolutely right that it's best to convert class year to years since graduation. But in this case, when I put class year into our segment, in this case, I found that when the class year goes down by 20.26 years, so in other words, they graduated 20 years more for every 20 years they graduated previously, their donor rate increases by 23%. And Power BI actually models this with a graph here, and it's got a trend line. Now, because Power BI isn't designed to identify all of this information, I put the trend line into Excel, and I just need to find it if I can. Oh, here we go. So what I did was I put the class year as a trend line. We have a calculation for that trend line. We can then identify the average that someone from that class year will make a gift based on that, the expected giving pattern based on that trend line, and we can compare it to the giving rate, the actual giving rate for that class. So essentially, we can say, oh, yeah, class of 45 gave at a 96.3% rate, which is awesome, but their expected rate was actually 98.59%. So maybe, you know, we could have expected actually a bit more from the class of 1945. Um, and you can compare it going down the line. You can see that this is actually a very close fit trend line because the R squared is 0.95, which is very high, but you can see there are a lot of bumps and wheezes throughout this,
Sorry,
and
Greg, we're
some
not looking at your Excel sheet.
ah, I always do that. There we go. Okay, so yes, here is
Oh,
the
bumps. There we go.
yep. Here is the trend line equation. Based on this trend line equation, we've plugged class year into this trend line. This is the number of years this is the number of percentage of donors we expect to make a gift, and this is the actual percentage of donors. And you can see that even though this is a very good fit, there are a lot of bumps and valleys in this trend line. Um, so, we could look at this and take a look at like from about 1960 to about 1966 and say, there's 5 years in a row where they were significantly below the trend line. What happened during those years? We can start to do some research on that. I realize we're getting close to the end here, so I'm going to try and wrap up real quick. Um, so having identified those significant factors, how much more or less likely are they to give, and can we stack them? Well, one of the ways we can stack them is to use naive Bayes. So let's take a look, for example, okay, how many donors with a certain address type, how many people with a certain address type were donors? And we can start stacking those type. Okay, how many people with an address home who were alumni made a gift? So we start identifying those characteristics that are more prevalent based on those factors.
And this is the part, sorry, this is the part where we can say, okay, what is the probability that we're going to get somebody's home address? And then that's the second item on the stack, and we build from there.
Exactly.
Yeah.
Yeah.
Okay.
So naive Bayes is just simply identifying the number of prospects we've got with each of these address types, identifying how many were donors, how many were not donors, and then taking the percentage of those. It's naive Bayes is really just identifying donors and non-donors who share certain characteristics by counting them up literally. So the next thing we need to think about when we're getting our really one of the last things we need to think about when we're doing this kind of project is which of these variables can we change for the better? Obviously, we cannot change someone's class year. And if someone is more likely to give their deceased, we cannot, as my stepson once suggested, hire a hitman. Um, what we can do, though, is we can say to ourselves, for example, with this trend line we looked at in Excel, hey, these classes 60 to 65 donors their classes are below the trend line. What are the things that caused that, and can we change those things? And then we need to look at some of the things they're easy to change. One of the things I did at a previous institution was um, we decided to look at envelopes. What was on an envelope? The first thing someone saw when they got something from us. And we found that what was on the envelope actually had an effect on whether they were going to open or not based on what cohort they were. So older men tended to open envelopes with young female alumni on them. I'm not going to get into why that was, but we changed up who we sent those various envelopes to, and we actually raised 20% more the following year. It was, yeah, and it cost us literally nothing to do that. So identifying that factor really, really did help us. And that's one of the best things about identifying these significant variables to kind of bust myths, uh, to to challenge accepted behavior. Now, that's something that's very difficult to put into practice because big organizations are like big ships; they're hard to turn around. But identifying those big wins from small changes is a good way to start with that. And the last thing let's say is that we have to kind of myth bust ourselves too, because sometimes we as data analysts or researchers assume that something is correct. And sometimes we even do a quick model and it looks correct, but we always have to kind of challenge ourselves and say, well, is it true that this segment is more likely to give, or are we just relying on our own anecdotes and what people have been telling us? So I realize I've run a little bit over. Thank you for staying with us. Any questions? I'm happy to get them. My email is on the is yeah, my email is on the
I'm putting it up now.
yeah, my email, yeah, Marianne is putting my email in the chat, greg@staupell.com.
Yeah, if you had to
Um,
leave, we're sorry. If you have questions for Greg, though, do you have a couple of minutes to hang out, Greg?
sure.
You haven't had a tornado go through your living room yet.
No, no, it's looking really dark out though.
Okay.
All right. Thanks. Any questions? Someone had something in chat. Oh, thank you, Alan. Yeah. Oh, thanks, Sanhita. Okay. Thanks, Sarah. I hope that this is kind of something that might challenge you to identify
Mm,
your
go
variables.
play.
So, mm, yeah. Well, thanks
Thanks.
everyone,
It's
and
good to see you, Liz,
yeah.
along with everybody else.
Would I use these
Sarah,
probability results in the
Michelle.
campaign gift
Yes.
type? Yes, I actually have in the past. I used it to build out a Monte Carlo document, and again, this Monte Carlo is a bit complicated to explain, but I do have
Yeah.
some training videos on them. But I plugged in the probabilities I found into a pyramid and identified, okay, how much are we going to possibly receive from each level of the pyramid in the coming year or in the coming campaign?
Greg also does work like where's the best place to host an event and
Mhm.
which events are more likely to bring back donors using his ex-wife's concepts. So yeah,
Not the hot dog events.
not the hot dog event.
Uh,
Yeah,
thanks, Donnie. Yeah.
yeah.
Oh, now I do want hot dogs. I haven't had lunch yet, so when you put that up, like, oh man, he's teasing me.
Doesn't look like we have questions, so I'm going to go ahead and shut off the recording.